there's any left over, you might be able to take some with you too.
Yeah.
I don't think I'm allowed to take them on the plane.
Probably not. All right, looks like we're live, so
We're good to go?
we're good to go.
All right. So when we do this back home in Belgium, we usually start by checking, since we are a country that has different languages, we have 3 official languages, we usually go, is there anyone in the audience that does not speak Dutch? So then we can do Dutch, but I guess that questions are the window here. Okay, English it is.
Flemish, Dutch, and French.
No, Flemish and Dutch is basically the same thing, but a different dialect. So we have Dutch or Flemish, French, and German.
Okay, of course.
All right, so thank you everyone for joining me here. It's nice to see this turnout. This session is about the .NET ABC of things you pretend to know about. The inspiration I got from this, and I think I was talking to you about that just before, our local matching and resourcing people and our recruiters reached out to me a couple of months ago saying, hey Nico, we run into all these technical terms, we need to find people for this, we have no clue what they mean, could you just give us a quick overview? And I thought about that and I put it in kind of like an ABC kind of thing, like in alphabetical order, just slides for every letter of the alphabet with a couple of technical terms, and just explained it. And within the hour, they got like a crap load of information. They remembered none of it. It was perfect. But I did send them the presentation afterwards, and now they are using that presentation as sort of a dictionary. And I was thinking this might be fun to do on a more advanced level then for .NET developers as well. So that was the session you chose, and here we are. Before I continue, a little something about myself. So my name is Nico. I'm a .NET architect at Inetum-Belgium. We're a worldwide consultancy company. So I guess we're competitors, basically. We have 27,000 people. How many do you have?
27,001.
So I've been with this company for close to 18 years now. It's been really fun there. I've been a Microsoft MVP in developer technologies since 2014, which is what brought me stateside. I was the MVP Summit, and I came over here for this beautiful brand of bikes. I co-run a conference in Belgium and Netherlands called Techorama. If you're ever interested in attending a European conference, I can really recommend this one. It's beautiful. I do a lot of conference speaking myself, mostly European sites. I ride a bike, I play some guitar. These are my socials if you want to follow me. No obligation whatsoever.
Still not calling it X.
I appreciate that.
Thank you. X is a stupid name.
It's so dumb.
Yeah.
All right. Just to do some quick housekeeping. We're a smaller group, which I love. That's awesome. Which means we can go off script whenever we want, as far as I'm concerned. I'm just going to do the talk. If you have any questions, if you want to see some extra stuff that's within my power to show you, just shout out and we'll go for it. You may raise your hand as well. There's no need to shout. All right, so this is basically how this started. We all had this conversation. I know I had this conversation. Someone comes up to me and says, hey, you know about this, right? I go, yes, I have no idea what they're talking about. At a certain point, it's just awkward to ask. So we all fake it until we find out what it actually does. That's basically what this talk is about. It's kind of a fun way to go over a couple of more advanced .NET topics. Some you will know pretty deep, others hopefully not. It's kind of a mix. We'll see where we end up, right? And I do promise you, I did not find stuff for every letter of the alphabet. So there are a couple of letters missing. I have no idea where we'll end up on timing. If we're running too late, just let me know and we'll cut short. By the end of this talk, if you feel that there's stuff missing, let me know, because I am planning on delivering this talk on different places. So it would be fun to get some feedback on it and to improve the session. And then we start with the A. A, I had Azure, App Settings, and AOT. And I was all going, I thought this was going to be advanced. I know what Azure is. But have you ever seen Azure? Like the building. So this is one of the, I don't know which one. This is one of the data centers. So we all know what Azure is, right? It's cloud computing. Now you're all going, yes, we know what Azure is. But we don't really know. So this is one of the data centers. They have a couple of them around the world. And we as developers were mostly on the software side of things. So we rarely stop to think about what does this thing look like? Because it's basically just a couple of data centers. There's nothing magical about it. It's the software that makes it magical. This is the inside, or at least a inside. All racks, all servers. This is just one hallway. The amount of hardware in Azure globally is insane. I don't have any actual numbers, but it's crazy. The fun thing is, these things tend to break. As we all know, servers break. They don't fix them up until a certain point. So servers within a rack have a certain percentage of failure. And for example, this one breaks, that's okay, we'll just, so the software makes sure that a different server takes over, everything keeps running, but this one doesn't get fixed because there are so many servers. If you want to fix all of them that break, you'll have people running around all the time. Right? That's just too expensive. So they're letting them fail until a certain point where the rack has too many failing servers, and then they'll just take out the rack and put in a new one. They replace the entire rack.
So you're scaled up, taking a card out of the computer, when you find the program out and just take a whole rack of servers out.
Yes, but the interesting thing is they take away the defective rack and they will start fixing it. And once it's completely fixed, it goes back into the backlog, so to speak, to go back in. It's time management. So many broken servers, they need to be fixed as fast as possible. They really optimized how fast they can swap out an entire rack of servers. It's, on the infrastructure level, this is insane. So well done. I don't know how up to date this is, but I think it's pretty close. This is Azure on a global scale. So every dot that you see are 2 data centers because they need to fail over. Every once in a while, they just shut the data center down to see if the failover still works. Sometimes it just shuts down without them noticing it because they forgot to renew an SSL server. That has happened a couple times too many. All right. So that was infrastructure. This is a list of, I think, most of the Azure services. There's just so many on them. And I've been having this discussion with with my managers, actually. So what we do is every year in September, we hire a bunch of junior developers and we train them for 3 months. And lately, my managers have been coming up to me saying, we need to train them better in Azure. Okay. Yes, because customers are asking Azure. Okay, which part of Azure? Yes.
Yeah.
And then I show them this, and then they're clueless. I still don't have an answer. I've been fighting this fight for 2 months now. Because basically, if your customer says we are putting our code on Azure DevOps, from a manager point of view, they're using Azure. They're using app services to host their web apps. You're using Azure as a web host, not as a cloud environment, but you're using Azure. And that's where it gets difficult. So just to give you an idea of the sheer scale of what Azure is. All right, next one. App settings. App settings is one of those topics, and there are a couple of them in this talk that I thought everyone knew. But apparently, not everyone knows them as deep as you would expect. So app settings, you know what I'm talking about, right? Yes, of course you do. App settings is in ASP.NET, mostly the JSON file that contains all your settings, your connection strings, your user secrets, your app settings. Very good. So your connection string is in there, other stuff that you need to be able to run your application. And you can differ this per environment, and this is all convention based by file name. So you have your app settings.development that runs when you press the file in Visual Studio. You have your app settings.production, that's when you deploy it. You can write your own custom environments and just add them to the list. And if all of these are not there, then it takes the normal app settings, which is. Okay. And I do have a small demo about this. It's not a place to store secrets. Oh man, I was not prepared. Visual Studio is not open. Let's start with a new project. We're just going to take an empty ASP.NET Core Web API project. That's all fine. Web Application 2 sounds like a wonderful name. And then I need my cheat sheet so I know what to do. Meanwhile, I'm enhancing my font size a bit so that you can actually read this. What are you doing? There's some codes. Is that big enough for everyone? Yeah. Yeah. Perfect. Almost there. There we go. So for my demos, I usually prepare a script so that I'm sure that I show everyone what I wanted to show. And usually I have it open by the time I start and I completely forgot. That's what you get with these pizza things. All right, here we go. Simple application, the app settings file is right here. We get it by default in the ASP.NET template. It has a normal non-environment one and then a development one. What's in there is very little. There's just some logging. That's it by default. So what we usually do is we go something like we add connection strings, and then we add a default connection like this, and then something in there. Or for example, we could go with app settings, or basically settings. Everyone loves typing JSON by hand, right? Such an amazing experience. Sorry?
So many quotes, right?
Oh, yes.
Quotes.
And then Visual Studio tries to be smart and adding a quote, but then sometimes you mistype a quote and you try to erase it, and then it adds extras and it goes bonkers. So I'm just going to quickly add 2 settings to this with quotes, something like this. All right, so I have defined my settings now. I don't want my connection strings anymore. Now I need a way to use these settings within my application. So what do we usually do? We take iConfiguration and we inject it. For example, by the way, have you seen these HTTP files? Have you seen them? That's pretty cool stuff. Since a couple of versions ago of Visual Studio, they add HTTP files, which basically gives you a built-in HTTP client to test your web APIs. So as soon as I press F5 to run this, there's a play button, I guess, that you can push, and it will execute a call. And you can add variables and authentication in there and whatnot. Pretty cool stuff.
Test your stuff.
Yeah, that's the way to work.
Yeah. Ever since Postman moved to like the online model where you can't save things locally,
Yeah.
This locally, I like better because it's with your code.
And it's one of those things where I didn't know I needed them, but when I first saw it, I was like, finally. All right. So this is a minimal API. That was the word. This is a minimal API. So there are no controllers. There's just this mapping of endpoints. Who hasn't used minimal APIs? Okay. Did you know the concept? Have you seen it? Okay. So basically, instead of writing a controller with the different methods, you in your program.cs, you just define your map gets, map posts, and you can put your logic there. Interestingly enough, we can also do constructor or method injection by going like this. Now my I configuration will get injected when this get method is called. For example, I can use this to give it the value of settings environments. It was called, I believe. Yes. So your iconfig is basically a dictionary kind of thing, like key value pairs. And by using the colon sign, you can go deeper into your JSON hierarchy. So we're in the settings object and we're taking the environment property. That's what we're trying to do. If everything goes as planned, this should give me my environment. This is such an exciting demo. There we go. This is coming from my app settings file. And from what I've seen at different customers working in different teams, this is how it usually gets done. But did you know that you could deserialize this into an object? See a couple of nods. All right, good, happy. So to do that, I first need an object, of course, which will be called settings. There I will have an API key and an environment. And then I can use my dependency injection to configure a settings object. And this will use builder.configuration, which is your iConfiguration thing. I will get the section, section being settings. Like that. So what this does is I'm telling my DI container to configure an object called settings, and I'm giving it an entire section of my app settings file. So instead of just going to one specific property, I'm taking the entire block and deserializing it into an object. With that done, I can inject it here, but I can't just inject settings. It needs to be an I options of type settings, and of course it needs to have a name. I call it settings. Now we can go settings, and let's say the value.api key. Now I have complete IntelliSense for all the different things that are in there. This was the API key that was in the app settings. So there's that. Anything new? No? Oh, you're smarter than most Belgians are. Which is good, which is good. All right, so just take it as a reminder then, just a refresher. Also, don't put user secrets in your app settings. Use Key Vault or something else. Ahead of time compilation. Ahead of time compilation has been around for ages as a concept. It first showed up in .NET, I believe, back in the Windows 8 era. I think. It was called RioJIT back then. It was the Rio compiler. It only worked for the .NET Store apps. Because that was a different runtime back then. And then it took like 5 years to bring the concept back. But now they're aiming big to go native with .NET. So what happens? If you compile your C# code in the past, you compile to intermediate language, and from that moment on, it just sits there. It waits. You start the application, your just-in-time compiler kicks off and will compile your intermediate language into native code. And it will only compile the things that you need and will keep compiling as you go on using the application. Right? With native AOT, you go from C# straight into native code. No longer intermediate language. It's still in there, but it gets translated in one go. So the symbols, the assemblies that you have on your device, on your server if it's a web application, on your PC if it's a desktop application, that's all native code. It also means that it's no longer in a DLL, it's in an executable. Everything's in the executable. There are some serious downsides on this. I have slides about that, I don't. So the big upside of this, of course, is performance. Just skipping an entire step or eliminating a step. So performance, startup performance, the runtime performance is way higher. And this is measurable. Depending on how complex your application is, this is even noticeable in usage. The downside is intermediate language enables a lot. For example, reflection. You can't do, or you're very limited in what you can do with reflection if you no longer have an intermediate language. So what Microsoft is doing now, at least that's what I think that they're doing if you look at the different pieces they're building, they're going to, well, I think the end goal is to eliminate reflection, but they're going to turn the usage down by a lot. An example where this is notable is a pretty obscure new feature in the latest version of C# called interceptors. I don't know if you've seen it, interceptors. It's interesting. It's an attribute that you can add that says the line of code that's at line 9, column 42, when you hit that exact line, instead of executing the method underneath, you need to intercept this call and execute this other method instead. It sounds completely bonkers. Why would you ever do that? Well, the reason that it's there is because they're using it themselves for backwards compatibility. They are rewriting a lot of stuff in newer versions of .NET to not use reflection anymore, but use code generators. System.text.json is a great example. Due to soft JSON used to reflection, system.text.json is just code generation. There's no reflection in there. So with the interceptors, they can just go code generation style, and if so, they can just go reflection style, and if the interceptor is there, they can go code generation, because then they know that you're on a newer version of .NET that supports these things. And they're adding a lot of stuff like that to eliminate the usage of reflection as much as possible. All to try to add more AOT stuff in there. So writing your own codes, writing an ahead of time compiled native application C#, it's not that hard. If you start a new application in .NET 8, it's just a checkbox that you can set. Or in your CS project, it's a line that you can. From that moment on, if you compile in release mode, not in debug mode, in release mode, that's important, then you will get an ahead of time compiled application. Why only in release mode? Because you need your IL to do better debugging. So that's why. You don't want to skip on your debugging experience. Also, compiling for AOT takes longer, like a lot longer. So only do that for release mode. And do be careful. it's not because you check the box that says compile to AOT that you will effectively have an AOT compiled application. As soon as you add a NuGet package that uses reflection, do the sub.json, for example, your compiler will see that and will say, I cannot compile this to AOT. I'll just go IL instead. Yes.
We've been using the word reflection quite a lot. Maybe other people knows what is it, but I don't. What
Okay.
is reflection?
Sorry, that was a wrong assumption of mine. Reflection is a set of APIs where you can change your application at runtime. You can call private fields, for example, that you normally don't have access to, and you can change their values. You can create completely new classes, all during runtime, like dynamically created while your application is running. You can inspect your entire application. It's extremely powerful. You can do so much with this. It's also very slow if used wrong, and very dangerous because you're doing it runtime. There's no compiler checks. There's no IntelliSense. There's nothing. And tools like, for example, JSON.NET or Microsoft.json, they inspect the different members of a class to see if they can deserialize JSON into it, and that's why they use it. And then with a couple of iterations of .NET ago, they added source generators, which takes away a lot of those needs. So that's reflection in a nutshell. Maybe I should add reflection to this. That's a good one.
What version was compiled AOT introduced? Is that 8?
I think so, yes. I think that was .NET 8. It is a continuation of what they did with RealJIT back in the Windows 8 era. But they couldn't do it for .NET back then because the Windows runtime, which was used to build Windows 8 and Windows Phone 8 apps, was completely different from the .NET runtime. It was built from the ground up. So they could break more things since it was newer.
Now things you could do with reflection, you can now do with source generators.
Exactly.
And it's way more performant.
Source generators are fun to write.
They're the best.
But they should upgrade them, that you no longer need .NET Standard 2 libraries. Okay, any other questions? That brings us to the letter B. Half an hour for one letter? All right, there are a couple of coming that I will go over pretty fast. We have Blazor and behavior-driven development. So Blazor, anyone doing Blazor? I'm doing Blazor. Blazor is awesome. Blazor is a new web front-end framework from Microsoft. And it's been around for 5, 6 years, something like that. It's their competitor for Angular, React, all that jazz. The best thing about Blazor, there is absolutely no JavaScript. That is, you can interrupt with JavaScript. You can add JavaScript libraries and call them from within .NET. And I believe since .NET 8, you can also do it the other way around. You can call .NET code from within your JavaScript. Not as an API call, because that's been around for ages. But you can have C# client-side code in your browser and you can call it from within your JavaScript. That's crazy cool stuff. Blazor comes in a bunch of different flavors. It's in WebAssembly, and once we get to the W, we'll talk more about WebAssembly. So basically, it means if you choose WebAssembly, it runs in your browser. You have native C# code running in your browser, client-side. Just like Angular would do, for example, but in TypeScript. Or you can go server-side. Server-side means you have a server component, which is basically an ASP.NET Core app that sets up a SignalR connection to your user's browser, a real-time TCP connection. Your user is interacting with the front end, commands get sent over that connection to the server. C# code gets executed on the server. There's a diff being calculated for the DOM. So the HTML DOM is known in server-side, it calculates a diff, And only the elements that have been updated are being sent back to the client browser so it can refresh his interface. WebAssembly, much faster to use, much slower to load. Server, faster to load, slower to use because of the connection, the back and forth. And now there's hybrid modes. And I forgot one. So hybrid modes has been around. It's not like really that much used. It's basically a way of using your Blazor components either in a mobile app or a desktop app. There's an element called the Blazor Web View, which is an element that you can use in WPF apps, I even believe in WinForms or in MAUI apps. And you can just put your Blazor controls in there. They are rendered as web components. It is a web view, but you can't call into native APIs. It is a native app at that moment. It's important to know. Now with .NET 8, we got static server-side rendering as well, which is the newest way of doing Blazor, which basically means that you can set render modes per component per page. You can have it set to static server-side, which means that there is no interaction whatsoever, just rendering. Or you can set it to server-side or client-side. Now what it will do is it will open the page using server-side methods, so it loads fast. And as soon as you start interacting with it, it will download the components in WebAssembly, so you can switch and go for the more performance. That's kind of their way of mixing the best of both worlds. The tooling, it's in separate projects right now. It's kind of involved to get it right. It's kind of complicated to wrap your head around it at the moment. But that will improve, I'm sure. By .NET 9 or 10, this will make sense. All right, behavior-driven development. Anyone doing BDD? I had to look this up myself because I heard the term and I didn't know what it was. So it's basically a way of writing codes that focuses more on the communication between business and development teams. So it's kind of a combination of test-driven development and normal agile development. But everything starts more from the business needs and less from the technical needs. I'm guessing most of us do this, but just don't realize that it has a name. It's just one of those things. Except maybe for this, the given when done notation, I haven't seen that much in projects. It's a way of writing your acceptance criteria that you can just put into some tools, and they will actually use that way of writing to run tests to make sure that everything works as it should. If you want to know more about that, here's a link that explains everything. I guess I can give you the slides, you can distribute them after.
Yes.
Yep. All right. Brings us to C. That was faster than 6 minutes. All right, containers. We're all doing containers by now, right? Docker, Kubernetes, fun stuff. Who has never heard of containers? Everyone? All right, great. But how do containers actually work? What are they? Because Docker is just a wrapper around containerd runtime. Just like Podman is, for example. Podman's different competitor of Docker. But what basically happens is you have your operating system, which sits on top of your hardware. On top of that runs your Docker engine. I'm choosing Docker as an example because it's the best known one. And on top of that are your containers. And every container contains the application layer of an operating system. It contains your application, it contains libraries, and it runs by itself. Your application has no clue that it's a container. As far as the application is concerned, it's running on an operating system, and it's all alone there. This is a continuation of virtual machines, basically. Where in virtual machines, we were also virtualizing the hardware and the operating system. Now we just need a certain layer of the operating system, certain parts of it, and the application logic and configuration. And that's it. interesting scenarios that this creates is that all the different Linux flavors, so this originates in the Linux world, right? Still most used there. But you got your Ubuntu, you got your SUSE, you got your Mint, and so on and so on. Since Docker relies on the Linux core, you can mix and match these operating systems. So your container is defined by a Docker file that has the configuration. It starts with an image. What image do you want to use? And the image could be, I want Ubuntu, which means this will be a Linux Ubuntu thing. It could be Windows. Windows works as well. You have images saying ASP.NET Core Linux, which means that you have a Linux environment with ASP.NET installed as a web server, and you can just publish in there, and so on and so on. But your host OS could be Ubuntu, and your image could be SUSE, and it would just work, no problem, because it's both Linux. As long as the versions of the cores that you're trying to use are compatible, it will just go. Very fun technology, very complicated to get started. The learning curve is high, from my experience. And once you wrap your head around Docker, Kubernetes comes along. Yeah. All right, back to .NET, the common type system. The common type system is what makes sure that we can have all these different languages and we can compile them all to the same intermediate language. That thing has a name, it's a common type system. And on this schematic, it's this. So you have your different languages, and these are just a couple. Some of them are not around anymore. They have all existed at one point. There can be more. You can write your own language. That's not too difficult. And then you write a compiler for it, and it goes into an intermediate language. And the thing that this enables is you can have a C# application referencing Visual Basic assemblies, and that just works. And we take that for granted, but there's an entire system that enables this. It goes even a step further. I've seen proof of concepts where there's a C# application that has Iron Python code in the same class and just runs it. So Iron Python, I don't think it exists anymore. It used to be Python.NET, basically, a Python dialect for .NET. So writing your own language, not that difficult. An example of that is the Rockstar language. Yes?
I might be a little bit ignorant on this, but from what I've seen previously, ASP.NET is part of this. I don't.
ASP.NET is not a language, it's a framework.
Great.
And you can use all these languages to write code in ASP.NET.
Love that. Thank you.
You did this, I'm sure.
I am missing F#.
Unless that was supposed to be the.
Q# is not .NET.
I thought that was.
We will get there when we hit Q. If you want to look at an example of someone who's built his own programming language, look for the Rockstar language. It's done by the same guy who made the UI UX sticker. He's a big 70s, 80s hard rock fan, and he basically wrote a programming language as kind of a joke. And if you read the syntax, it reads like the lyrics of a hard rock song. But it is a fully functional language. He even did a couple of Advent of Codes challenges in it.
And there's a bunch of those esoteric languages,
Yeah.
like Melville and Shakespeare.
Oh yeah, there we go.
I know there's one that's like visual based, like Qubit for colors.
Nice. That's what you get when you give developers free time.
Actually learned Snowball when I was in college.
Snowball.
SNOPOL, it was an AT&T, Marvell.
Something like that.
Yeah. It was very symbolic, very recursive.
Yeah.
I can
You
imagine.
literally have a 2-line program do the tower run on.
It was rough.
Impressive.
It was.
It was rough.
When it was slick, it was really slick.
Yeah.
but you had to get it there. All right, moving on. The CLR, the Common Language Runtime. This is where Microsoft naming gets confusing, as usual. So you got two versions of the CLR. You got the Core FX and you got the Core CLR, which only one of those has to do with .NET Core. Makes sense, right?
No.
So we'll get to this in a few letters as well. But you used to have .NET Framework, like from 1.0 up to 4.8, and after that came .NET Core. Right? At that moment in time, .NET Core was a complete rewrite. They started from scratch. They wanted to build .NET up from the bottom again in a more modern, modular, cross-platform way. So that's where they got the line. And one of the things that they had to do was build a new common language runtime. And the building blocks of that common language runtime are the same. This is what's in there. You have your base class library that contains all your system dots namespaces that we use to talk to .NET. And it supports for threading, meaning that if you do task.run in C#, it asks your operating system to launch a new thread or to take one from the thread pool. You can do code marshalling to pull in external assemblies, stuff like that. You get decent exception management. You got your tag checker. Looking at these, this is your full-on debugging experience and exception handling that you get. That's all in your common language runtime. Your compiler and your CLR are best friends. They're constantly talking. So CLR, the .NET Framework one, from 1.0 to 4.8, has always been called Core FX under the hood. Core FX was the name of the original CLR. Has been from the start. Is also the name of the GitHub repository where you could file issues for it. I don't know if they ever open sourced it though. I think you can just put issues in there. So afterwards came .NET Core, which needed its own CLR, and Core FX was taken as a name, so it just named it Core CLR. Basically, Core CLR, what we're doing now, Core FX is the has-been. Unless you're doing legacy support on applications, then you're still on Core FX. Anyone doing legacy apps? I'm sorry. Someone has to do it. All right, configure rate false. I'll just leave you a minute to read these two blocks of code. It's basically the same thing. The only thing that's different is this one says configure rate false. It's missing a bracket, but don't mind that. Just imagine that it's there. And this one doesn't, and only one of those two works. This is WinForms or WPF, whatever flows your boat. Which one works, which one doesn't? Any clues?
I wish I remembered what it meant.
That's why it's on the slide.
Every once in a minute, I see a typo on the bottom one.
Yeah, don't mind typos or misspellings. Beer might have been involved when I was typing this. Anyone want to make an educated guess?
I feel like the configure rate false tells the thread to keep going.
In what sense?
It won't wait for the thread.
No.
And I remember using configure wait for unpacking and packing, so I just can't remember.
Okay, just to relieve the tension, this one does not work. This one does work. And the reason why is, if you look at how async await works, how this async await works, really important. We're awaiting an HTTP client call. So what happens is you have your UI thread. This is the thread that does all the rendering. This is the thing that shows your visuals on screen. Every WPF, WinForms, MAUI app has a UI thread called the main thread. You await something, And awaiting something means that everything that comes afterwards is being registered as a callback that will be called at some time, at some point, and you are creating a state machine. So this is basically your old asynchronous programming where you used to register the callback first and then launch the operation. The only thing await the sync does is it flips that. So you can read asynchronous code in a synchronous way. That's what it does. So basically you await your code here. The actual call to the HTTP client gets scheduled on a worker thread. The version that you have here, the one that does not have configure await false, will do its work. So it will call the API, will get its data, and the callback will be executed on the calling thread. Not on the executing thread, on the calling one. That's default behavior. If you put configure await false, then you're basically saying to your asynchronous system, I don't care who called this, don't bother marshalling it back to the caller, just continue on the thread that you're on. Meaning that we're trying to set the content of a UI element that lives here from this thread, and it cannot access that object, so it will crash. Yes?
Is configure await obsolete in .NET 8?
No,
Okay.
but yes.
Oh, well, okay.
No, it depends. So ASP.NET Core, and I believe this was from .NET 7 even, no longer has a synchronization context, meaning they no longer play this game.
Okay.
So it's still there, configure await false, you can still use it, but it won't do anything anymore. As long as you're in ASP.NET Core.
So with this, even if you could, so.
That was crazy.
We're not moving it.
So in .NET 7 and .NET 8, if you use configure await, it'll always just go back to the UI thread no matter what.
Depending on what project type you're in.
Okay.
So they changed ASP.NET Core to no longer have to deal with this. But if you're doing WPF or a console application, then you will need to deal with this.
Okay.
Also meaning that if you, or at least this is the advice that they give you, if you are writing code in a class library, to still put configure await false there.
Okay.
Because the library might be used also by a WPF project.
Okay.
So the advice that they used to give is use configure await false everywhere except where you need to update the UI, because then it will fail for this reason. Having the task factory not marshal it back to the UI thread is a big gain in performance. Marshalling things between threads takes time. So that's why configure await false is there. Why is it not default? I have no idea. Probably because there would be too many people struggling with the UI errors, I would guess. But that's what configure await false does, and this is a very little known one from my experience. And well, if you're doing ASP.NET Core, it might not even matter anymore. All right, what's next? D. We have .NET, .NET Core, .NET Standard, and of course DDD. Do you know the difference between .NET, .NET Core, and .NET Standard?
Yes.
A couple of people. Especially, so .NET and .NET Core, most people can figure out. .NET Core and .NET Standard is where it gets confusing. So .NET, .NET Framework, .NET Core, .NET Standard are basically all the names. What Microsoft is now saying is that as soon as they talk about .NET Framework, they mean classic framework. The one that goes from 1.0 to 4.8. .NET Framework is old. .NET is current, from .NET 5 up until .NET 9, that's now in preview, and so on and so on and so on. So if you hear official Microsoft things, you read official blogs, you listen to live streams, that's the wording that they will use. Framework old, .NET current. Now, when they started rebuilding .NET Framework, to .NET Core, it was still called .NET Core because there was no feature parity. .NET Core was running behind a lot. Not a lot of stuff was there. And I think someone figured out they're still here. So that's why they named it .NET Core, just to make sure that you know you're using a newer version that's missing a lot of APIs. Now, at a certain point in time, you had .NET Core 1, you had .NET Core 2, .NET Core 3, 3.1, and then came .NET Core 4 next to .NET Framework 4. That's right. Might have been confusing, they thought. So what they did instead is, at that point in time, they reached a certain level of feature parity between the two. They're like, this is enough. The APIs that are still missing are so obscure and so little used, we'll just break here. And instead of confusing people even more by naming it .NET Core 4 or .NET 4, they actually made quite a smart move, I guess, and named it .NET 5. So the .NET Core 4 has never existed. They went from 3 to .NET 5. And from that point in time, they took on the original .NET naming. And they switched to yearly releases. Every even numbered release, so the one that we're on now, .NET 8, even numbered, is a long-term supported release. Release for support for 3 years. Every uneven numbered, .NET 9 that's coming up, is a standard support cycle, so 1 year. That's important to know. Meaning that in the 1 year cycle, so it's the uneven numbers, they will put in more experiments and more newer features, and they will use the even numbered ones more for stability and performance. And release date is always around October, November. So that's when you can expect .NET 9. Now, .NET Core and .NET Standard, they've all been unified now. It's just .NET. But what it used to be was .NET Core was your framework, and .NET Standard was basically a contract of that framework. You could look at it like these were the interfaces, and this was the implementation. That's kind of the way to look at it. And back then, you could create class libraries that were a specific version of .NET Standards, like 1.5 or 2 or 2.1, 2.2. And that would tell you which set of APIs were available in that class library, because it's the version of the contract that they defined. So .NET Standard 2.0 had less available APIs than 2.2. So why not just use 2.2? Because not every iteration of .NET Core would follow. .NET Core was an implementation of .NET Standard, and .NET Core was there on servers, on IoT devices, on mobile devices, on Xboxes, and they were not all updated at the same time. Especially Xamarin suffered from this. If you wanted to do Xamarin for the longest time, you had to stay on .NET Standard 1. Something. Even now with source generators, you need a .NET Standard 2.0 library, not a .NET library. So that's kind of the difference there. I'm assuming that .NET Standards will disappear at one point. Thank God. All right, domain-driven design. Yeah, pretty well-known term. It's been going around. There's the Blue Book if you want to dive into it. So domain-driven design is a design pattern coined by Eric Evans, who wrote a book about it, which is blue, which is why it's called the Blue Book. So if you ever hear someone speak about the Blue Book of DDD, that's the one. I've read it. It's pretty thorough. It explains DDD in great detail, but on an abstract level. It's not a book for developers, it's a book for architects. So if you want to learn about DDD and how it works on architectural level, that's the book to own. If you're a developer and you care about how to structure my code in a DDD way, there are better books. So DDD is a design pattern, again, that focuses on the domain. Everything starts from your business domain. Instead of writing entire applications that go from your business layer to your data access layer and your repositories and your services and whatnot. You start from your domain. And you model your domain, as we do, according to the real world, but not only its properties, but also how it behaves. The logic of a domain object lives within that object. So I know when I learned programming at school, they always told me, your models should not contain any logic. DDD flips out on it. Your business logic lives in your model or in your domain. If you want to get started with DDD in .NET, Clean Architecture is a really great place. Clean Architecture is a GitHub repository that explains DDD from a developer point of view, from a .NET developer point of view, and also contains templates, Visual Studio templates. You can just go found a project, Clean Architecture, look at the full DDD setup. With web APIs, with clients in Angular, React, whatever you choose. This nice little wizard. Laser's not there, that's not good. Should add it at some point. But you can just add extra projects to that. We've been using it, it's been great. It's fun. It does give you like 20, 25 projects in one solution, just from found a project. So yeah. Garbage collection. Garbage collection is one of those examples that could be a session all on its own. We all know it's there. We all kind of know what it does. It cleans up your memory, right? But how? How does it work? I have to be honest, I didn't know. I had to look this up because I was doing, at the end, doing a presentation on garbage collection. But okay, this is your managed heap. Stack and heap, we'll get into that a little later on. For now, this is your heap. This is where your reference objects live. .NET has two heaps. You have your object heap and your large object heap. If your objects go above 85,000 bytes, they get moved to the large object. Because that's a different garbage collection. So mainly we'll be living here. You should have tried to avoid to go there. Let's see. Your object heap consists of 3 generations. If you create an object on the heap, it gets generated in generation 1 or 0. Generation 0. If it stays there for a certain amount of time, then it gets moved on to generation 1. And then up to generation 2, depending on how long it lives. Most of the objects never make it to generation 1. Because at some point it just is no longer referenced, your garbage collector comes by and just cleans it up. And that happens in 2 steps. First, your garbage collector goes over all the objects, and the ones that are no longer referenced, they get flagged for removal for garbage collection. That's the first step. The second step, it actually takes all the flagged objects and removes them from memory. It's a 2-step process. But this is basically how your memory is structured. And why does it go across generations? Because garbage collection takes time. This is a process running on your machine for every process that you have. It's kind of like a sidecar thing. So the more it needs to check everything, if it can be cleaned up, the slower it gets. So it checks on generation 0, it checks regularly because there's a lot of stuff there, there's a lot of stuff moving back and forth, sitting in memory fast. Objects that after a couple of cycles are still there gets moved here, and here it will check fewer times. It does longer lived objects, and so on. Make sense? Right. When does garbage collection occur? There are 3 ways to do this. The third one is the one that you should try to avoid. You can trigger this yourself by calling gc.collect. GC is a static class in .NET. It is a collect method that triggers your garbage collection. That tries to trigger your garbage collection. It's never a given that it will actually get triggered. But you can try to force it manually. Never do that. The other 2 are automatic reasons. Your system is low on memory. We'll try to clean up memory. or there's a certain threshold on your heap, and once that gets crossed, it will collect. Trying to get back under the threshold, either by cleaning up or moving up a generation. Yes.
So when you have an iDisposable, when thing disposes, does that flag that the GC knows?
iDisposable just takes care of dereferencing everything, but it's still in memory until the garbage collection passes by.
And the garbage collection will be involved in destructor.
No, the destructor will already have been happened.
Yeah, by automatically it will happen. So whenever when we are making any putting any object inside the destructor, the memory will be deallocated, right?
That is a good question. I don't know. So your question is basically, does the destructor already clear the memory, or does it just wait for the garbage collection?
My question is like, will the destructor have the process of garbage collection?
No.
It just dereferences it and allows you an opportunity to clean things
See,
up
manually.
that you need to. Not every time you need to do that, but if there's something that you need to, that gives you the hook for you to do that.
Your garbage collector lives outside of your process.
It used to do its job automatically. We don't know.
Yeah. You can try to trigger it to collect methods, but there's no reason why you should. Are we doing on time? I think it's
So
just past the hour mark.
Yeah, 90 minutes is like the upper limit,
Okay,
so a half hour more.
all right, we'll keep going then. The stack and the heap. This is your basic computer science class, right? But people forget this, so quick refresher. Your RAM memory consists of stacks and heaps. If you declare an integer, it gets put into your stack. What's in there? It's a name, a type, and a value. If you, on the other hand, try to declare a class or object, it gets put on the heap with a name, a type, and an address. On the stack, you get another object that points to that object on the heap. Oh, that was too fast. That's what happens in memory. Difference between value types and reference types. Meaning that if you declare a second myClass instance and you set it to the same instance, or you do the equal sign trying to set the value, you will create a second reference type here that points to the same, second value type that points to the same reference type. Meaning if you change a value here, you change both. This is still a common question on interviews that we ask, that our customers ask our consultants, and we see too many failures on this question still, even with experienced developers. So that's why I included it. I see a lot of also people here still remember. That's great. Talking about interview questions, IEnumerable and iQueryable. Have you ever had these as questions on an interview? What's an IEnumerable? What's an iQueryable? I love these two. So an IEnumerable of T. An IEnumerable of T is not a collection. It's not a list. People use it as a list, but it's an interface, hence the I. And even then, even if you go enumerable, it's still not a list. It's an enumerator. Meaning that you have a collection of objects, you have an enumerator, and that can filter over those objects. But it will only do that as soon as you call for each, or if you call to list. Only that. I think I have an example. Here we go. So, as an example, we have a list of countries, 4 countries in the area in the list. I have an IEnumerable that uses a link query to filter on countries that start with a B. This case being Belgium and Belarus. Those are my 2 results. And then comes the interview question. What happens now? What is the result? So I have my list, I create my enumerable with the filter, then I remove an item, then I write it. Belgium will not be in the result anymore. Because at this point, this filtered countries object is not a list, it's an enumerator. And it will only evaluate its content as soon as you loop over it. Make sense? Questions? All right. Again, typical interview questions. If you do not know this, this is called deferred execution, by the way. If you do not know this, you will get into trouble at some point. Then there's iQueryable, which is comparable to iEnumerable. It even inherits from iEnumerable. But it's mostly for link queries, linked to SQL into databases. That's where it's mostly used. Why? Because this does not specifically target or does not specifically create an enumerator for a memory object. It creates a SQL query. So you still have your deferred execution with iQuerybles, but its execution happens on your database, not on your in-memory stuff. Entity Framework uses this a lot. So if they ask you what's the difference between iQueryable and iEnumerable, well, one inherits from the other, and one goes against the memory objects, the other one talks to your database.
I'm kind of like entry-level developer, and I just wanted to make sure I understood. So with the enumerable, you said Belgium wouldn't be in there.
Yeah.
Yeah, and then that basically meant it was removed before it got to the point.
Exactly. Yeah. So just switch back to that slide. The filtered countries. Look at it this way. At this point, filtered countries is just a query that's not been executed. Then you change your data source by removing an item, and then you execute the query. That's how you need to look at it. Why do you execute it? Because you're looping over it. The for each will trigger the execution of the query. That's what will happen. Another way to trigger it is filtered countries will have a .toList extension method that will do the same thing. That will trigger as well.
Thank you.
No problem. Which brings us to L, link. Are people still writing link queries this way? I haven't seen this in ages. So this is the original link. Link language integrated query was it's kind of like a sub-language to allow you to query different data sources from within your code. Remember the days when we had to write SQL commands and all that stuff, and just have magic SQL strings in our code? No longer.
No.
Sorry.
Having flashbacks now.
Yeah. ADO.net.
Yes.
Yeah.
There we go.
Yeah.
We are still doing that.
Yeah.
You still do that?
We still got legacy code.
Okay, so for people who still do this,
Good stuff.
Lambdas are kind of hard to understand if you're new to it.
so if you still need to write actual SQL queries in your C# code, interlaced, JetBrains has a great tool on this. And I don't know if ReSharper can do it, but if you're in Rider, you can connect Rider. So
Okay.
The lights are still on.
Microsoft, is that you?
I've never been here at this time of night, so.
So from within Rider, the Visual Studio competitor from JetBrains, you can connect to a database. And at that point in time, you can right-click a variable and say, this is, or you can select a string, right-click it and say, this is SQL. And you will get IntelliSense on that from that moment on. Because Rider knows your database, it knows you're doing SQL. You will get full IntelliSense on your table names, on your column names, and so on and so on. They can do this for CSS, HTML, and all those magic interlaced things as well. Really great tooling on that part.
And I can give away some free licenses to that, so.
There we go.
The JetBrain?
Yes, JetBrains, the ReSharper, or many of their other IDEs. Yeah.
This wasn't even rehearsed.
Yeah. I have 2 a month that I can give away. It's 100% off. Not that I'm promoting, I just like the tools.
Just be careful. Once you go ReSharper, there's no going back.
Yeah, but you can come back to me and then I'll give you another one because they stack. All right, just stay right there.
So ReSharper can definitely do the CSS HTML thing. I don't know if it can connect to the database. I don't think so. That will be right.
Yeah, you can convert back and forth. So if you write it this way, you can ask it to convert it to the other way and vice versa. I think it still supports that.
Oh, you mean link and lambdas?
Yeah.
Oh, yeah. I was getting to that.
Oh, sorry.
Okay, so going back to language integrated query, big advantage was this stuff gets compiled, so it's fast. It has IntelliSense, it has keywords, coloring, you can write logic in there. Great stuff. And we used to write it like this, kind of like an inverted SQL query. And as a target, you could go link to entity framework, so it gets converted into SQL queries that get executed. You can go link to XML, even straight to SQL. You can do a link to JSON. There have been tons of libraries for link to whatever you want. But now we don't do it like that anymore. We now write it. Like this. We usually do lambdas now. You can still do link. Link gets translated into lambdas by your compiler. So it's basically the same thing. Maui, one of my favorite topics. I've been a Xamarin developer for 7-8 years. A couple years back, loved Xamarin Forms. Maui is where the things went wrong. So Maui, not that one. That's also called Maui. That's an island in Hawaii. That's not it. So Maui is apparently still the island in Hawaii if you search for it online. So Maui is the big rename of Xamarin Forms. Right? They renamed everything into Maui Multi-Application User Interface because abbreviations are cool, but it's also a place. So if you try to search for it, you will find the island. However, if you Google or Bing problems with Maui, then you will get Microsoft links. So that's the way to do it.
You're still so Maui, but it starts talking about the issues.
Yeah, so Xamarin Forms, and I saw you nodding, so you probably used Forms as well. Xamarin Forms was quite stable. It had issues, but there were no issues and there were no workarounds. The community was quite big, it was really fun. But with Maui, things just broke. It's getting stable, but we're 3 releases in. It should have been stable on day 1. But okay, let's get there. This is the marketing slide for Maui. It's open source. It's on github.net/Maui. Basically, you write your application once using XAML or C# for the UI and using C# for the code. And it runs everywhere, from Windows to Android to Mac to iOS. Write once, run everywhere. That's basically the premise. How does it work? You have your operating system at the bottom. On top of Android, iOS, and Mac, you have your Mono runtime. Mono being the open source Unix, Linux implementation of .NET, which is also owned by Microsoft since they acquired Xamarin. On Windows, you have your core CLR, which we talked about. There's your base class library on top, and then you get .NET for Android, .NET for iOS, and so on and so on. For Windows, it's SwingUI 3. So these are different layers that everything goes through, right? Then there's Maui. And this is where the API set that you write against. and your app code lives there. And everything trickles down. The fun thing about Maui is that you're actually writing native code. This is a cross-platform framework. It's not a web-based framework. It is native code. How they do this is they write wrappers around Java and Swift. So if you select or if you put a button on screen in Maui, that's actually a native Android button, a native UIKit button, a native as well. So the look and feel is native, the bugs are native. If there are bugs in the platform, in the online platform, you will run into them in Xamarin as well, or in Maui as well. Q#, there we go. Not .NET. It is a Microsoft language, but it's designed for quantum computing. It's originated as a quantum computing language and has then evolved into a Azure quantum development language. Anyone doing quantum computing? Crazy stuff. So quantum computing, instead of bits, you're working against qubits, which cannot be just 1 and 0, but can be them both at the same time. That's quantum for them. And your qubits being 1 and 0 at the same time is called superposition, which means that if you need to evaluate different solutions based on 1 or 0, you can evaluate them at the same time, which gains speed, for example.
Is this for like a lot of fast computing or like a lot of data or
It makes certain problems easier to solve.
Okay.
Exactly that,
Okay.
certain problems.
Certain-
Nice.
Wrapping your head around that thought process is, we're not quantum computers.
No. These things will crack compression algorithms and hashing algorithms and insane
I see.
speeds.
Big problems,
Yes.
tough problems,
Yeah.
right? Okay.
I think matrix stuff works well with quantum computing. So
Yeah.
but it's definitely a niche problem.
Yeah.
Yeah.
I did see Apple recently said they upgraded their iMessage to be quantum proof, for.
We'll see.
Yeah. I just thought that was really fun.
You had the same thing happen when clouds were coming up. So all of a sudden, every provider that provided you with web space had a cloud. It's the same thing happening again.
And now everything's AI too.
Yeah. My God. Yep. If I hear Copilot one more time.
No, it's never.
Okay, so next to qubits and superposition, you also have entanglement, which means that if one qubit changes its state, another will change as well because they're dependent on each other. And these are a couple of the things in quantum computing that they use to calculate things. I guess this is as far as my knowledge goes. I even forgot to put a snippet of Q# code just to show you. It's good. This is the currently largest quantum computer that there is. This was built or finished in October last year, and it's the first one to go over 1,000 qubits. It's by Atom Computing. Older, so before this, the biggest one was IBM one, 433 qubits, something like that. And they have to supercool everything to maintain those qubits. This one is based on capturing atoms in a 2D plane with lasers. So they don't need to cool them so hard. It's more energy efficient. They're making really big leaps in quantum computing. I'm kind of curious and scared at the same time. Especially cryptography will have problems. Because things that would take thousands of years to crack with normal computers will take minutes.
Yeah, way more bits, so you get way more scale.
Yes. You need, depending on the calculations that you do, you need between 400 and 400 qubits to do the actual calculations. So it's not adding one qubit that gives you extra, you need to add more in order to scale up. But it's going quite fast.
So we have, just to give a time check, there's probably 8 minutes left before the hour and a half. So if you want to leave time for questions, or we want to continue with this. But I like this topic, so we can get this one going.
You like records?
Yes.
Are they some new?
Sorry,
Are they some new?
say again.
Nice and you.
Yeah.
Yes.
These are records of fun. Don't use records everywhere. Records are a new reference type unless you use record struct, then it's a value type. They are immutable by default, but you can make them immutable by just writing out your properties and giving them a setter. They are different from classes in the way that they are constructed and destructed. So don't just use them everywhere instead of classes. A really great place to use records are DTO objects because of the fast, small way that you can write them. So this is a record definition for those who haven't seen it yet. It's basically the same as a class definition. The parameters that you pass it, that's your constructor. So every parameter here becomes a property within the record. That's how you define it. In latest version of C#, you can also do this now with classes. But then they turn into fields, not properties. There's a difference there. Schematics solidify. If you think it can be immutable, then you can use a record or a class. But please don't make your records immutable. Just because you can does not mean you should.
I think some of the nice things about records is you can, like, you know how you normally two lists, or sorry, you say two objects, or you try to compare them. Records have built-in comparisons.
Yes.
Well,
So you don't have to implement it yourself, right?
The whole point of COBOL is you could say the record A equal to record B, and everything was built into it, and it would just do the comparison.
You don't have to implement equals yourself.
Slides I've left.
And that's why using it for like DTOs and things of that nature, it suddenly becomes nicer to use, because you can say, is this DTO the same as this one? And it'll do the right thing without you having to manually do that yourself.
Right. In thing of time, I have structs, I have task and task of T, trimming might be less important, and WebAssembly, and that's it. Pick and choose. Task.
All right.
So.
So for the coming hour, we'll be discussing tasks. So task object is an operation. We talked a bit about this in the await to sync story. It's an operation. It's not an actual result. It might be executed on a different thread. It might not be, depending on what you're putting in the task. And this is also a big misconception and also a big interview question. A new task, so if you await something, you get a task. No, that came out wrong. If you await something, you get a task result. If you have a task, it's an operation, an asynchronous operation. Asynchronous is not multi-thread, never. It can be executed on a different thread. If it's IO-bound work, like calling into the file system, calling an API, then it will be scheduled on a thread pool thread. If you're just doing basic calculations, it will not happen in a separate thread. Even if you await it, it will just happen. And await async and the task object has in .NET has set a bar for asynchronous programming. JavaScript has adopted the same model. Languages have. They were the first. Sharp was first. And they have evolved greatly. So coming back to this, we've seen this slide before. It's the exact same one, nothing new. You get your call back. You are maybe scheduling somewhere else, maybe not. That's on the slides. If you await something in your code, your intermediate language will contain a state machine. And state machine is quite a complex piece of intermediate language code that checks the state of your task while it's being executed. And if you await, like here, you await something, so it will wait until the task is completed and it will put the result here. That's what the state machine does. It's non-blocking, so everything just keeps going. Unless you leave the await keyword out and you call .result or .wait. Do not ever call .result or .wait, because you will effectively block your thread. I have seen literally 2 months ago, a developer with 25 years of experience with a line of code like this with .wait at the end complained that everything froze and he didn't know why. And I had to explain. So don't be that guy. Also, don't use async void except in event handlers. That's the only place where you're allowed to. Why? Because async voids will swallow any exceptions. You will, if things crash, you will not know why. Use async task. Task, the non-generic task is the same as void, basically. It's the asynchronous version of void. Anything else? So if you have, for example, private async task, whatever, and you only have this line of code, only the await, then it's a performance optimization to leave out the async and the await keywords. You just return the task. So you have private task, no async, and you just return the call task. Why? Because every time you write await, a state machine gets created. And if you can just return the task, then the method that's called into this method also has a state machine, because that awaits this one. I only basically need one state machine to keep track of the state. So it's optimization. Yes.
I want to say that goes somewhere. Is it the one like return task from result, in that case text, or is it another like return task for the aspect?
Task from results you can only do if you put async there.
Okay.
Then you're effectively giving back a result. If you leave async out, then you can return task.complete task, for example. Something like that. All right, with that, I think we're out of time. So if there are any questions, I think we'll be hanging out a bit.
A few minutes.
Few minutes. So if there are any questions, feel free. If not, thank you all for being here. I had fun. I hope you had the same.
Was your slide deck going to be available?
Yeah.
Yes.
Thank you.
It's very good. I really appreciated the attention to detail and the talk, just to give everybody like
Thank you.
baseline and the history behind it is what I really like as well.
Thanks.
And I have 4 JetBrains, so how many people need one? All right, I got 2, 3. All right, and then 1 for anyone else. So we'll just do it when we end the text streaming. I'll just do this.